All right. Good morning or evening or whatever it is in your time zone. Campers, I'm going to wait just a second for the stream to catch up with me. So I think I mentioned yesterday that the stream is... Oh, there we go. Yeah. Just checking to make sure that the audio quality is good coming out of YouTube. I think I mentioned yesterday that there's a little bit of a lag between where I am and where you guys are seeing. So, yesterday we learned about relational databases. We learned about what they are, when you would want to use them, and how to integrate BigQuery and Kaggle. And there were some questions on the forums, and I think I got to most of them. I actually haven't spent that much time on the forums today, so we'll take a peek after the first half hour. Sorry, let me re-situate myself. There we go. Yes. So that's what we learned yesterday. Today, we're going to start writing SQL. And there were some questions this morning about, where's the SQL, Rachel? So far, this has all been in Python. And that's what we're going to be doing today. The three commands that we're learning today are select, from, and where. And you're going to have these in every SQL query, basically. I guess you might not have where sometimes, but especially for a very large data set, like all of the BigQuery data sets, you are almost always going to want to have a little where clause in there. And I mentioned yesterday, just a little vocabulary before we jump in, that the sort of chunk of SQL that you send to a database to get information back is called a query. And queries are made up of various clauses. And the clauses are based on keywords. So select, from, where, group by. We'll learn different clauses as the course progresses. And you can think of these as verbs, just like in human language, so they're functions. And then you can think of the various tables or data sets or columns as nouns. So we're going to do verb, noun, verb, noun, verb, noun, and that's sort of the way that the syntax works in SQL, more or less. So let's just get started. Again, I'm going to not look at the chat because I will get super duper distracted if I look at the chat until we hit about the half hour mark, and then I will answer your guys' questions. And if you're just here for the sort of me talking portion, you can hop out there, and that is absolutely fine. Okay, so today we're learning our first three SQL clauses or verbs or functions, select, from, and where. And to introduce these, we'll work with this little fake database that has one table. So a table is just like a spreadsheet, and with 4 rows and 3 columns, or 4 records and 3 attributes, if you remember our vocabulary from yesterday. It's a reference. This is a reference to a podcast I like called The Adventure Zone, and that's why it's a weird name for a rabbit. So, the first verb that you're always going to use in a SQL query is select. So this is going to tell SQL what column or attribute you want information from. And you're always going to use from, and this says, what table should we look at? So here is a little sample query. We have select name. So name here is the column, and from is the name of this table. So on Kaggle, all of the data sets that we have are in the BigQuery public data place, I guess. You can think of it sort of like a GitHub repo. That's where all the data sets are contained. And then within there, you need to specify which specific data set you're looking at. So this is a fake one called Pet Records. Yesterday we worked with Hacker News. Today we're going to work with OpenAQ, which is an air quality measurement data set. So you need the name of the specific data set that you're looking for, and then the name of the specific table. So you can think of this like a little address that's like, this is the table that I want the information from, and then select says what column or columns you want. So that's a general idea. But like I mentioned, BigQuery datasets are big, like many, many terabytes big. And on Kaggle, you only get, I believe, 5 terabytes worth of queries per 30 days. So if you ask for, a bunch of columns from a data set with millions and millions of rows, you're going to not be able to run very many queries. And we don't always want all the columns in our database either, sorry, all the rows in our database either. So let's say I'm doing some analysis for Kaggle, and we are wondering how many people have used the Learn lessons in this month. Well, I don't need to know about every single kernel or little code sample that everybody wrote on Kaggle. I only want to know about the ones that are in the Learn lessons. And so to figure out that, I use where. And where lets you say what row quality you are interested in. So here we have this very tiny table. I keep wanting to say spreadsheet, it's a table because it's a database. We have this very tiny table, and in the animal column you can see we have rabbits, we have dogs, and we have cats. And I might be interested in the names of all of the cats. So maybe I'm writing some sort of cat name generation, machine learning algorithm. And to figure out what the cat names are specifically, I can say select name. So I'm getting the name column from, and this is the table we're looking at. So you're always going to have BigQuery public data if you're working on Kaggle, because that's the data sets that we have available. If you have your own project on BigQuery, this will be the name of your specific project. And then I'm saying in the pet records database, the pets table. So this table is called pets and it's in pet records. And where animal equals cat. So what this will do is it will look through the animal column. It will find all of the rows where animal is cat, and then it will give me the name values for each of those rows. So these happen to be together in the order, but if they weren't, I would still get these results back. So that's the basic idea of select. Tells you about the columns. From tells you where to get those columns from. And then, from tells you where to get those columns from. And then where tells you which row qualities you're interested in. And especially with BigQuery, you're almost always going to have a where clause. A couple other things to notice here looking at this query. You can see that we have three little quotation marks above and below. That's because we're going to be sending this to BigQuery as a text string. So I mentioned yesterday that we're using the client. So a client's like a little messenger. And the query is going to be a little piece of SQL that we hand to it as text, and it will take it over to BigQuery and then pass it to BigQuery, and BigQuery will evaluate it as SQL and be like, yes, this is good SQL, here's your data back, or like, there is no table called, I don't know, pet dentures or whatever, there is an error message. You can't have this data because it doesn't exist, and then your messenger will take it back to you. And so on and so forth. So the SQL that we write is actually going to be in text strings in Python, and then we use this little Python wrapper, this client, to send it to BigQuery and get it back. So let's work through an example. So you don't actually need to work through the examples in the lecture notebook unless you really want to, but you are free to. And I'm going to, just so you can see what the output is and we can play around with them a little bit. And just a reminder where to get these. So all of these lessons are from the SQL course, Intro to SQL on Kaggle Learn. Oop, I made it big again, sorry. And Kaggle Learn. And then within SQL, today we are doing select from and where, and that's what I'm going to be going through. And then your exercise to do is this exercise, select from and where. And when you click on it, you'll create a kernel for your work, and I can get rid of this. And this is a Jupyter notebook, if you're familiar with this, that has all of the information that you need to just follow along and do the exercises. And if you have any questions, feel free to ask them on the Learn forums. So I saw some questions about where are we going to write our code. It'll be in this notebook. And then later, if you want to go back and find your work, probably the easiest way is to go to your profile. So I'm clicking on my profile picture up here, and then I clicked on my profile. And then under kernels, I can see that this is still running. So if I click onto it, I don't have to restart it. It's just going to already be there. And it'll stop running eventually. And you can also see that it is the top exercise here in my the tab called My Work. So if you want to go back and find any of your work, that's probably the easiest way to do it. All right. So I didn't actually want any of that. So let's go back. Here we go. So I want a new kernel, and we're going to be using this OpenAQ dataset. So I'm actually going to go and find that dataset on Kaggle. And create, what was it, OpenAQ, and create a kernel on it. So here we have the dataset OpenAQ. You can see that it is BigQuery. If I click into it, I can see more information about it. I can see information about what the table looks like, actually. So I can see the all the attributes. And you'll notice it mentions that you're not downloading anything. So when you add this to a kernel, or when you create a kernel using it, what you're going to be doing is creating a connection that you can send your little client through, and client can come back through. Start a new kernel, a notebook kernel, and starting it from the dataset like this means the dataset will already be attached to your kernel. If you have an existing kernel, you can find the BigQuery dataset you want by adding it as a data source. And if you have your own data on BigQuery, you can add it through this setting here, which I'm not going to talk about too much because I think most of you are probably not at that stage. Oop. Am I going to sneeze? No? Okay. Frustrating. Okay. So let me call this select, which is the way to get columns from, which tells you which table to look at, and where, SCRATCH, pad, where, which tells you what qualities, that the rows need what qualities in order to grab them. And I don't actually need this intro code. I'm going to copy and paste from the notebook here. So what this code does, and we talked about a lot of these recently, and by recently I mean yesterday, and you can go back and watch the recording. So we're importing the library that tells us how to create the client. This, in the BigQuery package, there is a sort of like description of what a client does. And we're going to take that description and create a copy for ourselves. And then we are going to create a little pointer to our data set that we're interested in. And to do that, we say, hey, the data set that I want is OpenAQ, which is this one that we've added to our kernel. And it's in the BigQuery public data project, which is where all of the public data on Kaggle is going to be. And here I'm going to go and get that reference to that data set. So this is sort of like giving your client messenger a map and saying like, hey, really quickly, can you figure out how to get to this project? Yes, okay, we're good. And then here we're going to list all of the tables in our data set, and there should only be one, if you remember from when we were looking at the data set. And then we're going to print the names of all the tables in the data set. And I did look down. Python comment is actually going to be the hashtag or the pound symbol or the number sign. Triple quotes is just a string that's over multiple lines. So you can see that all of this is a single string. Sorry, I was not going to look at the comments. No, I'm not going to look. All right. Get rid of that, don't need any of that. So this should print out the name of the single table that we have in our data set. If we had multiple tables, we'd get the name of all of the tables. So, and that's just copying and pasting the code from the lesson. And you can see we get the same information out. And here we're just going to look at some of the rows from the data set. So, from our dataset ref, that's sort of the directions to the specific dataset we're interested in, we're going to say, hey, I also want a map that tells me directly how to get to this table, global air quality, which is the only table in this dataset. And then I want you to get the table and show me the first 5 rows. So this will print out the first 5 rows of the data frame. They will print out the first 5 rows of the table as a data frame. And this is a review of what we did yesterday, but I think it's good to go over. And this is just to let you see what's in the data set, what it looks like, what your values are. And it's just like using, it's just like using the head command in Bash or Python or R or whatever it is that you're using. Excuse me. Okay. So we've done that. We know what's in our data set. We've got city, country, pollutant, value, timestamp, et cetera, et cetera. If we wanted to see the information about each of these columns, or if we had a lot of columns, we could do, I believe, because this is the reference to the table, it is schema. Yeah, yeah. Nope. There we go. Okay, it's not a function. It's just an attribute that it has. So this prints out the list of all the things that are in our data set. So you can see that we have location, which is a string. It's the location, a string, which is the location where the data was measured. We have averaged over in hours, which is a float. The number of hours the value is averaged over. And this is just more information about what's in the data set. So this could be really helpful if you are working with something and you've never seen it before and you're trying to figure out what's in there. All right, now let's write a query. So we have a little sample query here that, again, I'm just going to copy and paste. Triple quotes mean that it's a single string, so this is a little text string that we're passing through. You will notice that select, from, and where are uppercase, and everything else is lowercase except for country equals US. That is by convention. SQL is case insensitive, so you can use whatever case you like. Most people, and to make your code more readable, choose to have the verbs or these clauses in all caps, and then the rest of the query in lower caps unless, the table is called something with camel case or whatever, and then you generally follow the convention of the database. And again, that just makes your code easier to read. So this query is going to select city, so the column city, which we can see is a column in our data set, so that shouldn't be a problem. From BigQuery public data, which is always going to be the same because all of our data sets are in this project. And then finding the OpenAQ dataset, which is the dataset we're looking at, and then the global air quality table, which is the only table in that dataset, but we still need to specify which table it is. And then we're only going to return the rows where country equals US. So we're going to get a list of all of the rows in the dataset. We're going to get a list of all of the rows in the data set where country is United States, and we're only going to get information from the city column. So this is going to be a big list of cities in the US, and there's probably going to be some repetition because we're not saying we only want one of each. We're saying that we want all of them, if that makes sense. So that's what that query is. And I think we already have a client object, so I don't know why we are, yeah. So we already have a client, so some of this is maybe a little bit repetitive, there we go. Now that we have our query, which is a string, which is valid SQL, we can actually use our client to send the query to BigQuery. So we have a client. We have the client object, has this function query, and we're going to send it this query that we've defined up here, and then we're going to call that query job, except I didn't run this cell, so it's like, where's my text string? Ain't none. There we go. So here is our query job. And in order to get the information out of it, so we've got our messengers come back and he's like, I did my job. And I'm like, okay, great. Can you give it to me as a data frame? Because that's how I want to work with it. So I can ask him, or I don't know why I'm saying it's a him. I guess because medieval messengers were usually dudes. I don't know. I probably shouldn't gender. Classes in Python. Convert to data frame. This will convert it to a data frame, and then if we look at this object that we've just created, nope. What if we spell it right, huh? There we go. You can see that it is a long list of cities that have a lot of repetition. And also we can tell that this database has, it looks like a couple of different, not conventions, like things are entered in a different way. Styles, so it looks like Alaska Nope, not all of Alaska, because Anchorage is lowercase, but some of these are uppercase, and then this one just says Forest Service. So what this tells us right away about this data set is that there might be a little bit of munging and data cleaning that we need to do, and we can't just assume that these are all going to be good city names that we can use for geocoding directly, for example. And that's helpful to know. And we can also see that there's 3,561 rows, so that's how many rows in this data set, so specifically in this table, have US as country. So we have a lot of information from this query. And we can also do, regular panda stuff. And if you are not super familiar with pandas, that's absolutely fine. So this is a reference to this data frame here. So again, a data frame is sort of like a spreadsheet object in pandas or R. We're going to look at the city column. So this is the name of the column, and you can see that this column is named city. This is a function, and you can tell because it has parentheses, so it's a little verb, and it's going to count all the values. So it's just like a bar graph. It's going to go through and say, okay, I've seen Fairbanks, 8 times or whatever. And then rather than having the whole list print out, we're going to print out just the first 5 rows. Difference between Python and R: Python is the first 5 rows, R is the first 6 rows. So 1, 2, 3, 4, 5. You can see that we've got 87 measurements from Phoenix, Mesa, Scottsdale. We've got 82 from Houston. We've got 63 from Los Angeles, Long Beach, Santa Ana, and so forth. So this is summarizing the information that we have in this data frame here. And we can run some more queries. So this one is going to select 2 columns. So it's going to select city and country. And it's going to do it from the same place where country equals US. So something that you might choose not to do here is not to select a column that you are also filtering on if you are only choosing one value, right? So if we run this query, and let's do that real quick. This one. And actually, let me put all of this code. Ooh, that's too much. I selected the wrong thing. Copy just that. Nope. Just this. There we go. Copy. No, copy it. There we go. Yeah. And I'm going to put all of these in a single data frame, and I know there is a Jupyter shortcut to merge cells, and I never remember what it is, and that's okay. And then nope. I want it in a single cell so I can rerun it repeatedly multiple times. No cities. Okay. So this is going to create a new query. We're going to send it to the client. The client's going to go and get it. We're going to say, okay, I want that same thing, but as a data frame now. And then we're going to print out the first 5 rows of the data frame. And we will get a different result than we did the first time because we have the city column and also the country column. The country column will always be US because we asked it to only give us rows where the country column was US, if that makes sense. So if we wanted to do, going back up and looking here, let's say source name instead. That would be a little bit more informative. So that would tell us information on the cities, where country is US, and the source name. So let's modify our query a little bit. Instead of saying country, let's select source name. It's going to take a second to run. Interesting. Okay, so this source name must be just like the state of Texas gave us this data, rather than it being from the country as US, because that's always going to be the same in this query, if that makes sense. So just sort of like helping you guys think through what's in the queries. You can also do this. Select star means select everything. And I'm going to urge you guys to be a little bit cautious when using select star on BigQuery because BigQuery data sets are very big. Again, you have a limited amount of query data that you can pull every month. And if you say select star without the where, you're just going to get this whole data set. And this isn't an especially big one. But if you said select star from like the GitHub data set that has all of the GitHub commit messages or whatever's in there, that's going to be it. That's going to be your query. And also it probably won't fit in your kernel memory. So BigQuery will give it to you, and it's like your messenger's holding this like big basket of stuff, and it's trying to get into your local environment, which is smaller. Like you can't get through the door. I don't know. I'm trying to come up with a helpful metaphor for this. And that means that you still paid for the messenger to go and get all the stuff and bring it to you. It's just not going to be able to give it to you because the object is physically too big to fit in the space that you have for it, if that makes sense. So you can use select star, but be ye warned, it can be very tricksy. And let's see what this gives us. So we're going to do the exact same thing. And I will note that it's a little bit inefficient for me to do what I'm doing here because I'm actually getting the whole data set. So I could have just changed what select was. I don't know why I copied and pasted the whole thing. So I'm actually looking through the whole data set and I'm getting all of the data, but then I'm just looking at the first 5 rows. So maybe not the most efficient use of my time. Select car from blah, blah, global air quality. So it should give us everything actually. Oh, I see. And it hasn't because I had an extra queue in query. So if we run this again, yeah, there we go. Oh, something you might have noticed is that the second time I ran the same query, it was much faster. There's lots of fun little tricks in BigQuery, and one of them is that it will cache your recent queries. So if you run the same query multiple times, it should be pretty fast to get the same data out. And I don't remember how often they clear the cache, but after a while, it will stop being so fast, and then it'll have to like go through everything again, and then it'll have like a little bundle for you to pull on. Okay, so now we have the first 5 rows, and we can see we're getting all of the columns. There's not a lot of columns in this data set, but some data sets have a lot of columns. And we're only getting the information where country equals US. Talking about the some of the format stuff that we've already talked about. And again, just be aware that there are limits. Fortunately, we don't just sort of toss you into the deep end. There is a function in the BigQuery client that will let you calculate how much data your query will take. So this can be very helpful if you are playing around maybe with a new data set. You don't really know how much time your query is going to take to run, and you can check that. So let's actually say, so we don't have Hacker News attached to this data set, so this isn't going to work. Let's actually do open aq dot blah blah air quality, global air quality. There we go. And we had it lowercase up or above, so I'm just gonna make it lowercase here. And let's actually select star where country equals US again. So we're just gonna, actually no, let's do a different country. Let's do India. I can never remember ISO country codes. So this is going to go through, it's going to get everything in our data set where the country is India. And instead of actually running the query, it's going to do a dry run. So it'll basically, it's like a dress rehearsal. If I did run this, how much data would it take? And then it will tell us how many bytes it will take. And you can convert these to, gigabytes or megabytes is, that's something different. That's where you talk about eating, I guess. And you can use this to check and make sure that you're not going to send out a really big query. And you can also use this as a little bit of a, you can also run queries with a little bit of a seatbelt. So if we have the, so this is the query function, and we are passing it in this same query here that we've defined here. And there's also an attribute that we can set, an argument we can set job config, and we can say that we want it to be safe config. And I believe that we do need to define what that's going to be. So this is, we could do other things here, but we are going to say, oh my gosh, why can't I copy and paste? Here we're going to say that I only want to run jobs if they are less than 100 megabytes. And I'm just like doing the math for that. Because remember that this is returned in bytes, not megabytes or gigabytes. So I can create a little instruction manual, if you will, that tells our client, hey, I only want you to run this if it's not going to take too long or if it's not going to take too much time. So if we run this, I think this will run because this is less than 100 megabytes. Yeah. So let's actually do 10. Let's actually do 1. 1 megabyte, because I believe it's less than 1 megabyte here. I just want you guys to see what the what's it called? Error message is. Oh, nope, it was still less than 1 megabyte. Less than 1,000 bytes? Yeah. Okay, this should work. I don't think that's 1 megabyte anymore. Nope, it still worked. Oh, it's because it's cached. Oh, I need to write a new query. Okay, sorry, I figured it out because it'll send you the information if you're going to use more than that against your quota. And if it's cached, it's not going to count against your quota because it's already run it and it's sort of like got it on standby just in case you need it. So let's do US again. How much is that going to take? Okay. Yeah, there we go. So now we get an error message, and if we scroll all the way down to the bottom, you can see that we're getting this error because the query exceeded limits for bytes billed. So it's not just the size of the query, it's how much of the query you would actually be charged for if you had your credit card set up and everything, but we're not doing that. So hopefully that was helpful. And you can use that little, safety belt to make sure that you're not making really big queries, which is helpful. And then this is just another query that they have increased the number of bytes. So they've changed the instruction manual and said, hey, instead of really small queries, I'm okay with slightly big queries. It's okay. I know it's going to be a larger data set. And then this time it runs just fine. All right. So... So let's actually increase this back up to 1 megabyte, which should be enough. Query exceeded. Okay, so it's not going to be enough. So let's go back to 10. I could just do the math for this, but let's call this query max size bytes. There we go. Instead of changing what the function is called every time we change the number of max size bytes. Or higher required. So let's do 100 times. I'm sure you guys are telling me all about the math that it should be in the comments here. There we go. So when we increase the size, we get the information out instead of an error message that says we were looking for too much. Okay, let's answer some questions. So I am going to first commit this and then I will make it public. And this time I'm actually going to finish making it public. So you guys should be able to look at this and play around with it if you like. And if you make a BigQuery, if you make a kernel that's associated with a BigQuery data set public and somebody forks it or makes a copy and then makes some changes and runs it, that'll be run against their quota and not yours. So there's no problem there making that public. Cost says 1024, not 1,000. Yeah, thanks. All right, so let's start on the Learn forums and then I'm pretty sure it's just Learn Forum. Yeah, it's just Learn Forum. There we go. And this is also the if you got the email today, at the end of the event, I'll be going through and finding some of my favorite questions and answers from the Learn forums. And if you ask a really good question or give a really good answer, I might send you a t-shirt. They're special SQL Summer Camp t-shirts, and they're so cute, and I don't know if I'm going to get one, and I'm a little jelly. But yes, so ask your questions on the Learn forum. All right. 400 error, cannot explicitly modify. Interested. Okay, somebody's answered that. I don't know what the answer to that is. Question, we can talk about aliases while learning select and from. Oh, okay. We will talk about aliases. That might be in the second part of the course. That's the answer to that question. Bad request error in exercise 2. Okay, and here is the answer to that. So let's give that an upvote if you are having that error. Different databases for practice. We worked on a crime data set and a few others. Is there a place where we can find more BigQuery databases like the one we've pulled up in the course so far? If so, how do you know what to type for the dataset name parameter in BQ helper? Yeah, so the name should be the name of the dataset on Kaggle, all lowercase. So if we go to datasets, boo, 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 and we filter based on, I think it's a hashtag. Will that search for tags? Yeah. And you filter based on hashtag BigQuery. You can see all of our BigQuery data sets. So we've got some Bitcoin ones. We've got some just like sample ones. We've got ones of public patents. So if you're interested in patents, that could be cool. We've got open images, Ethereum. There's a lot of like cryptocurrency data sets, Medicare data, name data. And if we look at the data set, here we go. You can see that the name of the data set is Patents Public Data Google Patents Research. Is this a notebook for this specific data set is my question here. Yeah, okay, so this is a notebook for this specific data set, and you can see that the data set name is patents. And I will say that this does use a slightly older version. Originally, we wrote our own package to use BigQuery on data sets, BigQuery on Kaggle, and then we changed our curriculum so that we're teaching you how to use the client instead of homebrewing your own weird thing, which is what we did. And there's much more help available for the client than there is for this little package that Sawyer, who's one of the competitions folks, and I just sort of like worked on our own. So, but that's how you find the name. And patents public data. Okay, it isn't actually the name of the data set. So good question. I would poke around in the description. All of them should be fairly well documented. And if they are not, feel free to drop a comment in the discussion. All right, let's do one more on Learn, and then I will turn to the chat. Some questions, and I'll go through these and take a look, and hopefully other folks can also work through these. So here's one on SQL, not Python. It feels much like a Python course instead of a SQL course. No, it's fine. I know this will not be received well, at least by the content creators. No, it's fine. How Python fits in the scene, why the class isn't 100% SQL. The title is Summer of SQL, not Summer of Tools that use SQL. Yeah, that's a really good question. So the reason is that that's the way that we, have it set up on Kaggle. And even though this is kind of a lot of Python, it's still less work than setting up your own access to BigQuery on your own computer. And we also, I don't have the capacity to be available to everyone who's having trouble with their own computer and, different distros and OSs and all of that stuff. Yeah, again, you can copy and paste literally all of the Python in this course, and I encourage you to do that. And depending on where where you're working in data science, you may have to do quite a bit of futzing to get connected to the database. You're not always going to be given, direct access to, a database and then a nice little place where you can just write your queries and write SQL, which is, that's ideal. That's really nice. But a downside of that sort of like GUI graphical user interface approach to working with SQL is that it's much harder to script things. So if you have a query that you need to run, let's say, every 14 days for some sort of metrics report, or you are doing active learning on your model and you want to make sure that you're updating it with fresh data. If you have a language you're comfortable with and that you can use for scripting to send the SQL queries back and forth, I have personally found that to be much more efficient use of my time. But yeah, no, I hear your comments in the spirit in which they were given, and I agree, it is a little bit of Python to get started. So. All right, let's check out the chat. Shakar says, if the results of any query is empty, will it only show column names or return something like empty result? Rachel, if you were not a data scientist, what would you choose to be? Yeah, let's find out what happens if we send a query, and I will answer that. Man, I don't know. I really like data science. I really like having a job where I can do some more. Hopefully not a real country. Oh, right. Yeah, so it just returns the names of the columns, which makes sense because it's going through, it's looking at everything, and we're saying, hey, only give me things where country is blah, 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 blah. And there aren't any countries where it's that, so it just gives us 0 rows back, but a data frame of 0 rows. I don't know. I was apprenticed to a jeweler in high school, and if I hadn't gone to college, I'd probably be a jeweler. So I guess that's the answer to that question. Deviant says, how does dry run query calculate how many bytes it's going to take without actually running the query? I have no idea. An engineer built something, they just sort of know. I have no idea. Yeah, it's a good question, right? It's a little bit of chicken and the egg. I don't know how I'd do that. Leslie says, if I want to select specific criteria, i.e. selecting cities that start with the letter S, can we write that in the where query, or does the criteria have to be an attribute? That's a good question. I'm trying to think of, let's see, SQL, regex. Postgres, that's the wrong one. MySQL, that's the wrong one. BigQuery. String functions in standard SQL, there we go. All right. Code point to bytes, so that's not going to be super helpful for us. Okay, so this is doing sort of like operations over strings, but I'm interested in string. So what I want is to write a regular expression that looks for like a star, for example. So that would be a followed by any number of any characters. A dot star. Code points to bytes, ASCII characters. Rot 13. Why would you do that in a database? Code points to string. Nijanthan says you can use where city equals S, let's say I, and it looks like percentage symbol. Let's see if that works. Nope, I actually want to run it. Actually, I should probably be doing these up here. Okay, so it looks like that might not have worked. Does it need to be lowercase? Yeah, okay, so that's not returning anything for me, Jonathan. That might also be something that's different between different flavors of SQL. It's just one of those things where there's very slight differences between the ways that you would write syntax in different places. Yeah, that's a good question. I don't actually know. I will look it up. Sancharam says their guess for how you know how many bytes a query is going to look at is that it's based on the metadata of the database. I think that's reasonable. Yeah. Oh, here we go. People are saying like, where country like I $sign. Country, did I spell it right? I did spell it right. It is the right. I'm getting something back. Interesting. Let's look up BigQuery really quick. BigQuery. Nope. Query. Like. Operations. Okay. String. Unary. String and byte. Value does not match the pattern specified. Okay. How do I specify the pattern? Arithmetic operators. No. Bitwise. Not helpful. Logical. Still not what I'm looking for. I'm looking for string comparison. Oh, it should be in capitals? All right, let's see if that works. Yes. Okay, so that's good to know. Oh, that makes sense. That makes sense. So it's case sensitive, and I was assuming that it was not case sensitive like the rest of SQL. But it makes sense that this is case sensitive because we're matching against a specific string. So I'm wondering if it is all lowercase. Am I going to get any results? Nope. There we go. What have I done? Unexpected string literal. There we go. Okay. Yeah, okay. So when you're using where, that is case sensitive. And that should give us all countries where the country ISO code begins with I, except we are looking at the head. Okay, sorry. So what I was figuring out for myself there is the SQL itself is not case sensitive, but the strings you pass to be evaluated are case sensitive, so they're looking for exact matches. I feel like there's a flavor of Microsoft SQL where it's not case sensitive. Possibly. All right. Robbie says SQL is case sensitive. Richard says, but the field values are. Okay, this is helpful. Thank you. Shiraz says, is there any way to use auto-completion in the SQL query string? Would be helpful. Unfortunately not on Kaggle because this is, I mean, it's a string and there's no like, it's not being parsed in the kernel. It's not being evaluated in the kernel. It's being sent somewhere else to be evaluated. And the kernel is using Python rather than SQL. So if we try to treat this as SQL code, this is just going to be a bunch of errors. So if we try to treat this just as Python code, which is what would allow us to use so let's try to use if we try to use tabcomplete here, so we move it into its own code cell because tabcomplete never works in strings, at least in most IDEs. Maybe it does in some of them, but not one that I have used. It's going to try to complete it using Python syntax rather than SQL syntax. So unfortunately, you are on your own for double checking your SQL syntax, which is a little bit frustrating, but also good for learning because then when you find bugs, I find it is the most helpful thing for your coding development is to figure out what you messed up. So, blah, 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 blah. And Matu is saying that it is from the metadata table. And Pavan, he mentioned let's see if this works. Regexp contains .star mentioned that we could use regex using this unidentifier. Okay, so it looks like that might not be something that's in BigQuery. That might be from another flavor of SQL. Oh, that's in Cyrillic, so I'm sorry, I do not know how to read that. How to view the total amount of memory used for all my queries, which I write on Kaggle. I don't believe there's a way to do that currently. But I will double check, and I will definitely post on the forums about that if we've added one. The last time I asked, there wasn't one, but it's very possible that the engineers have sneakily added it when I wasn't paying attention, because they tend to do that. Did you guys notice I don't know if it's been rolled out to everybody, but you can upload images directly in forum comments now instead of having to create a link somewhere else? Pretty cool. And that's just like, I was writing posts one day, I was like, oh, that's nice. Little sneaky surprise. Can you check your query usage? Yeah, and I'll post on the forums either way. Yeah. And folks are helping me out with something a little bit ago. Again, there's a little bit of a lag between where I am in time and where the chat is. So, and the coffee mug is I just got a green one. Subash says, I'm asking about the backticks used to enclose the table name, not the whole query. Yes, so that's a good point. The name of the table, like the specific address, does need to be in backticks, and that's just the syntax that BigQuery is looking for. So if I change it to this, and just to show you on, oh, I don't think my cord's long enough. Wait. If I unplug my keyboard, I will be slightly upset. So on a standard keyboard, as shown in the United States, the backticks are over here on the number key, and we are not using the quote marks here next to enter. Because if you've never used backticks, they can be a little bit hard to find. So if I change my backticks to quotes, I should get an error. Yeah, so I get an error because it's a bad request, and it has no idea where I am actually going to be looking for this data. It's interpreting this as a string, and it needs to be in backticks so that it parses it as a little address. So if I replace these with backticks, then it works. Why? Again, I am pretty utilitarian in terms of using SQL. I use it to do the stuff I need to do, and I don't pay a lot of attention to the inside workings, because that seems like not the best use of my time, maybe. But, let's see other questions. Lots of people helping me with my queries that I didn't notice at the time. Sorry, guys. Let's see. Regular expressions. Yeah, I'm still not sure. So I guess like would probably be the closest thing, but it looks like it's not, so it's not Perl syntax for regular expressions for sure, which is what I'm used to. Let's see if we can get Perl syntax. Regex BigQuery. All right. So let's find, so regular expression is regex, there we go. Okay, so it's regex contains, oh, I think somebody posted about this, and I think that I used the wrong syntax. So this will, okay, it uses RE2, which is helpful. To know what flavor of regular expression it's using. And I think this will tell us, okay, so this is a little bit more complicated of a query, but what we're doing is we are looking in a table that has the field email in it, and we are also going to create a new column using a regular expression. So a regular expression is a way to evaluate strings. And if you're interested in learning about regular expressions, I would recommend chapter one of speech and language processing because it goes into a lot of detail and is, I found, pretty easy to follow. And it's it's a very fast way to evaluate strings in terms of like how fast it is to run. It's based on Perl, which is an extremely fast language. It's very easy to make mistakes because it is hard to read them as a human being. So I would recommend sort of minimizing your usage of regular expressions as much as possible and try to, like if you're trying to do something like find all the HTML tags in a document, see if you can do something like parse it as HTML and then use tools for manipulating HTML rather than writing a regular expression to get them all. That's just my personal preference. And I think it's a lot easier to avoid weird bugs. But what this is doing is it's creating a new column and it's calling it is valid. So we haven't talked about aliasing. We'll get to that. But that's what that as is. It's basically giving a name to this variable. And it's looking in the column called email. And then it's checking whether there is part of the string where there is one @ symbol followed by at least one lowercase character between A and Z, uppercase character between A and Z, number between 0 and 9, or the dash symbol. So one or more of those will work. Followed by a period, and this little slash here means this period is the period symbol, and that's what I'm looking for, because on its own, in regular expressions, the period matches any character. And then after the period, we have one or more characters that are all the lowercase characters, ASCII characters, all the uppercase ASCII characters, 0 through 9, the dash, or the period. So this would match this because we have an @ symbol. We have some letters that fall in this little range here. There's at least one of them. We have a period, and then we have additional letters and numbers at the end. Here we just have 3 letters. So this is true. It's evaluating whether or not this regular expression is true given this input string. This one is also true. This one is false, and this actually fails right here because it's looking for the @ symbol and it doesn't see one. So regular expressions in BigQuery is sort of the that's the idea, and we've got about 3 minutes, but let's quickly write a little regular expression because I am interested in this. I don't think I've previously written regular expressions in BigQuery, so it'll be a fun adventure for me. Nope, I didn't want to move it. I want a new one. New one. There we go. So there's, nope, that's not what I wanted either. So I'm going to copy and paste this. And instead of selecting star, we're going to select, what do we want to do? Let's get all the pollutants where there's a number in the name of the pollutant. So things like NO2 and O3 and not things like CO. So let's select, where was I? I've lost my place. Let's make that smaller. Okay, that helps. So whoop, we're going to select pollutant and we're going to, let's not do the where clause. And we're going to create a new column. Let me double check the syntax again. First, we're going to say what we want things to look like. Boop, boop. So we're going to use a regular expression that contains, we're going to look in the pollutant column here. And actually, there we go. I want a regular expression and I want one or more numeric character between 0 and 9, and we're going to call this has number. And this should return 2 columns, one that has a pollutant and a second that returns whether or not that pollutant has a number in it. So pollutant here, you can see this has no numbers, so we've returned false. This one, these all do have numbers, so we've returned true. And if we wanted to do something a little bit different, like, what was your original question? Country contains country, and we want it to be, I think you said an S followed by any number of characters. We may need to specify that the S occurs, and it should be a lowercase or an uppercase s because we know that the like little strings that are evaluated are case sensitive. Starts with S. This may give us all columns. What'd I do? Did you mean country? C-O-U-N. Yeah, I did mean country. Let's spell that right. This may give us a column that tells us if there's any S anywhere in the query, rather than if it starts with S. And I'm actually just going to print out the whole thing. Whoop. Let's see if we've got one that has S in it. Yeah, okay. So this is not starting at the beginning of the string. It's looking anywhere in the string. Oh, regex start of string. I don't remember what the, there we go. So if I want it only at the beginning, I need to put a little, little hat at the front. And hopefully that's from the same flavor of regular expressions as we had. Yeah, okay, so we've fixed the problem where it matched any S anywhere in the string. And let me say what this does really quick. Returns, I'll get rid of that, returns all, returns countries and a new column with whether they start with S. Whether, if they start with S. Okay. So that kind of answers your question, because that's how you create a new column that has that information, but that's not necessarily how you get just those columns. And I'm pretty sure that we could actually then refer to that where starts with S equals true. So this should only return the ones where it's true, except, okay, well, we'll deal with that later, because we are going to talk about aliases a little bit later on, and I think that's a good thing for that lesson. All right, it is time. Thank you for joining me, everybody. I could see that the chat was very lively, and I appreciate everybody jumping in and helping each other out and asking good questions. If you have other questions, please feel free to ask them on the Learn forums. And if you want to help people out, please also jump in the Learn forums. And we will come back tomorrow where we will talk about the next lessons, which are group by, having, and count. So this is going to let you, instead of just returning whole columns or columns based on a specific row, we're going to be able to do a little bit more aggregation and, have data that's a little bit more condensed and informative. All right, so I will see you guys tomorrow. Feel free to ask questions on the forums, and we will have the last day of week 1. It's very exciting. We're almost there. Okay, thanks for joining, everybody, and I'll see you tomorrow, campers. I think I can say see you tomorrow like 4 more times before the end of the stream, so bye.